cases. Okay? And also if whether sine, cos, and tan are negative or positive. So we can come to some general conclusions because of all of this information. Okay, so if you're given a ratio, you want to use your calculator to first find the related acute angle, beta. Okay, you always want to use the positive ratio. So for example here, if I give you sine theta equals -1/2, okay, then to find beta, you would do the inverse sine of 1/2. Even though this ratio is negative, you always use the positive version of the ratio because beta is always acute. Sorry. Because beta is always acute, okay? So no matter what this is, you always find the positive version. And so then you would find that beta would be 30 degrees. All right? So then you use your drawing of the angle on the Cartesian plane, what you know beta is, to find theta. Okay? So sine theta of -1/2, it could be -1 over, y over r. Okay, so we'll talk about that later, how you would draw it. But this is it. So you use your calculator to find beta, and you're drawing on the Cartesian plane to actually find the principal angle. Now the primary trig ratios, sine, cos, and tan, can be positive or negative, which is we just saw on the previous example. So to determine where the sign is positive or negative, you have two options. Now I prefer option 1 because it actually demonstrates an understanding of why sine, cos, and tan are positive where they're positive and negative where they're negative. Whereas this cast rule is just memorizing a rule. So you have to kind of just decide which kind of student you are. If you're someone that wants to go and take mathematics in university or past high school, you really should try to use logic as much as you can. If you're just in this for high school or because you have to take this course, I mean, the cast rule is fine. The cast rule is also fine as a backup to the logic, okay? But r is always positive, so therefore consider, so the radius is always positive. So therefore consider whether the quadrant in question has negative or positive x and y values. So for example, if you're looking at sine, so sine x is y over r with our new definition, okay? R is always positive. So sine x will be positive in quadrants where y is also positive. So here and here, quadrant 1 and 2. But sine x will be negative in quadrants where y is negative. So quadrants 3 and 4 have the negative values for sine. Cos x, is x over r, okay? So cos will be positive in quadrants 1 and 4 where x values are positive, but negative in quadrants 2 and 3 where x values are negative. Now tan is actually y over x. So you can actually think about this in terms of slope. Okay, so like change in y over change in x. So in these two quadrants, if you drew a line here or drew a line here, the slope is positive. Because you have y over x, positive over positive, or negative divided by negative, you get a positive ratio in quadrant 1 or quadrant 3. But in quadrant 2 and quadrant 4, you'd have a positive divided by a negative, or a negative divided by a positive, or you can think about it as lines drawn there have a negative slope. So in those two quadrants, tan is negative. Okay, or you can use the cast rule. So the cast rule shows where each ratio is positive. So you start here in quadrant 4 and you spell C-A-S-T. And that tells you where cos is positive, all of the ratios are positive, sine is positive, and tan is positive. So for instance, if you are drawing something that terminates in quadrant 2, you would go C-A-S, so that means sine is positive there, but cos and tan are both negative. And that's how you use the cast rule. Okay. Given that sine A is equal to 3 over 5, and that angle A lies in Q1, determine the exact values for cos A and tan A. So we always, when you have questions, you always want to actually draw it if possible, because this will help you visualize what's going on here. So sine A, it says A is in quadrant 1, okay? So A is here. And we know here here's theta, or sorry, not theta, it's called A in this case, capital A. Okay, and we know that sine A is 3 over 5. So sine A is 3 over 5. Well, we know that sine is y over r. So that means the y value has to be 3, and the r value has to be 5. So therefore, we need to find the x value so that we can find cos and tan. So if we look at this as just a right angle triangle, you can see that 3 squared plus x squared will be equal to 5 squared. So you get x squared is equal to 16. So x is equal to plus or minus 4. But because it's in this quadrant, we know that it's equal to just 4. So x is equal to 4. So now we can find cos A, which we know is x over r, and sum in our 4, so 4 over 5. And our tan of A is y over x, so in this case, 3 over 4. Okay, determine another angle between 0 and 360 degrees that has the same sine value. So ignore these cos values now. We're just looking at the sine value. How are the two angles related? Well, so we're having a sine A of positive 3 over positive 5. So where else could we have a positive sine value? So what quadrants have a positive sign? Well, this is just y. This is r. R is always positive. And the 3 represents y. So that means either you could terminate in quadrant 1, like we drew up here, or you could terminate in quadrant 2, okay? Because if you have a positive y value, your x value could be negative because they don't give us cos or tan in the original problem. They only gave us that sine was positive. So it's also possible that A, so we'll call this A2, could terminate here. All right? That's also possible. Now, it could not terminate here or here because either one of these, in these quadrants, would have negative sine values since y is negative in both of those quadrants. So then this would be positive 4, sorry, it's 3 over 5. So this would be 3, and this would be 5, and this one here would actually be negative 4, okay, because the ratio still works with the right triangle, okay? If you were to do Pythagorean theorem, you would find this to be 4. But because it's in this direction, we would label it as negative 4, okay? So how is this related back to A? So how is A2 related to A? Well, the related acute angle beta, so the related acute angle of A2 is equal to angle A from above. So beta in this case is equal to 8. All right? So if two principal angles have the same sine ratio, that means their related acute angles are the same. Determine another angle between 0 and 360 degrees that has the same cosine value as in A. So our cosine value here was 4 over 5. Okay? So cos of A was positive 4 over positive 5. So drawing a terminal arm in this quadrant wouldn't work, okay? Because cos is x over r. So x is not positive in this quadrant. X is also not positive in this quadrant, but it is positive in this quadrant. So you could have a terminal arm here. We'll call this A3. that would meet this criteria. Okay, you could draw, again, a right triangle up from here, where this is positive 4 and this is 5. Okay? The difference in this case is that the y value would be negative 3 instead of positive 3. So it doesn't have the same sine value as here, but it does have the same cos value. So because it has the same cos value, then that means that this angle beta will be the same as it was there. So beta, so the related acute angle of A3 is equal to the original A. So we'll call this beta 3. So beta 3 is equal to A. So it shares the same related acute angle. So if I asked you to actually find all these angles, how would you do that? Well, you would just use your inverse functions, right? So the values of the angles. So up here, you could do the inverse of any of these, but you have to make sure you choose a positive ratio. So I'll do the inverse sine of 3 over 5, and that's approximately 37 degrees. So therefore, A is equal to 37 degrees. So that means in this case, beta is equal to 37 degrees. So A2 is equal to 180 minus 37 degrees. So you get 143 degrees. In this case, A would be equal to, what was I going to say? 360 degrees minus 37 degrees. So that's equal to 323 degrees. Okay? So put this in your calculator, cos of 323 degrees. You should get approximately 4 over 5, about 0.8. All right? So you use your calculator to find this 37 degrees. And then you use the position of the terminal arm and the position of the related acute angle to find the size of the principal angle. Okay? So it's very important that you know how to determine where each ratio is positive or negative. That's key to understanding the rest of this. All right, 2 more examples. I know this is a long one, but it's a lot of stuff to understand. So example 3, point negative 5, 7 is on the terminal arm of an angle. Write the value, or determine the values of the primary trig ratios, the value of the related acute angle, and the value of the primary angle. So first we draw the terminal arm. So point negative 5, 7 would be something like here, okay? It doesn't actually matter how accurate you are, but as long as you're in the right quadrant. So now we have to label where theta and beta are, okay? And the right triangle. So here's theta, the principal angle. And this is beta in here. Okay, remember, you don't ever show a direction on beta, it's just an acute angle, but you do show this direction on theta. Okay, we know this point is negative 5, 7. We can draw the right triangle here. So this is negative 5, and this is 7. So we need to find how long r is. So r is the square root of 49 minus 25. Sorry, plus 25. Just making sure I'm doing this right. Okay, the square root of x squared plus y squared. So, oh man, I drew this in the wrong quadrant. Just as I was saying, make sure you get the quadrant right. All right, I knew this wasn't right. Okay, so negative 5, positive 7, that's up here. Okay, negative 5, 7. There we go. Okay, so this here is theta, and this here is beta. And we can draw our right triangle down. Okay, so this is -5 and this is +7, and we still need to find r. So r is the square root of 7 squared, so 49, plus -5 squared, so 25, because -5 times -5 is +25. So r is the square root of 84. Sorry, 74. All right, so that was step 2. So now we can find the primary trig ratios at this point. So the sine of theta is equal to y over r, so 7 over root 74. And that's an exact value. You should leave it that way. You shouldn't turn that into a decimal. Okay, unless it's a word problem where we need time or money or something, you should leave it as an exact value. Cos of theta is x over r, so -5 over root 74. And tan of theta is y over x,